Welcome back to Chemistry is Cool. Today we're going to learn how to balance an equation. And so I'm going to use practice activity 6.2, and it is put out by sciencespot.net. Thank you to them, and it is called Balancing Act. And so the basics of balancing an equation are that atoms are not lost or gained during a chemical reaction. We have to understand that the conservation of matter says that atoms cannot be lost or gained. And so even though a chemical reaction takes place and it may look different, and you may see something really cool happen, which is what we really want to see happen. But understand that there are no atoms lost or gained, okay? And so that's what a balance in a chemical reaction does, is it shows you that. So scientists know that there must be the same number of atoms on each side of the equation or chemical reaction. All right. And I like to abbreviate reaction RxN. So the equation or reaction. Okay. So to balance a chemical equation, you must add what are called coefficients. Coefficients. They're big numbers that go in front of a compound or an element. Okay, so you must add coefficients in front of the chemical formulas and the equation. You cannot add or change any subscripts. You cannot add or change the subscripts. Remember, the subscripts are there because it's made this a balanced form. Made it a balanced formula for that compound, or in this case, this subscript is here because O is what is called a diatomic, or it always has two. It cannot exist alone. So when oxygen exists, it never exists alone. There's always two of them. And so here, the magnesium oxide, the magnesium has a +2 charge, oxygen has a -2, so those are balanced by their charges, so they have no subscripts, and we cannot add a subscript to that. That is already written. How it is written here is called a skeleton equation. All right. So this here is what is known as a skeletal equation. All right, in chemistry, we call it a skeletal equation, which is just the basics, not balanced yet, but it's just the basics of putting the atoms or compounds all together into the equation, okay? And so that's what that is called. Okay, so how are we going to go about balancing one? Well, you see, I've already kind of set up, I put some the guys at ScienceSpot put blocks here. I've changed it a little bit because to show the method, which I believe is the easiest and the simplest to walk through. And so the first thing we want to do is determine the number of atoms of each element. So we're simply on each side, okay? And so we look and we see magnesium and has one on this side and one on this side. Now notice I have already written magnesium down underneath what is called the yield sign, or the arrow in a chemical equation. And so underneath I wrote the elements, and remember that means capital letters signify new elements. So we have Mg and we have O, so that's why I write them right up under there. Okay, so literally it's like we have two sides of that we have to make sure are balanced. 1 and 1 of magnesium, awesome, balanced. Oxygen, we have 2 on this side, subscript 2. And on this side, we have 1. Unbalanced. Cannot leave it like that, because a chemical reaction will never be unbalanced. Okay, I'll never have something that's unbalanced. So we need to get 2 oxygens on this side. Well, how do we get 2 oxygens on this side? Well, the only thing you can add is coefficients. And so we can add a 2 in front here. Now that gives us, when we add this coefficient, understand it gives us 2 magnesiums. So we have to change our total, our counting total down here. This is our tally of how many we have. So now we have 2 magnesiums, and it gives us 2 oxygens. Okay? Once we have that, so now we have balanced oxygens, but our magnesiums are not balanced. And so in order to get 2 magnesiums on this side, we have to, again, add a coefficient. That's going to give us 2 there. So now we have 2, fully balanced. And now this is what is called a balanced equation. Okay? Balanced equation. This down here is only our tally to keep up with what we've done up here. We don't do anything down here until we've done something up here. Okay? So this is only a tally to make sure that the balance works out. All right, so there's your simple introduction to it. So let's try a few of these together. Let you pause. I would encourage you to pause it here and try them on your own, and then once you have yours, then put it back, play it again, and see what you got. All right, so you can go ahead and pause the first one. Okay, so here we're going to put our elements underneath the yield sign or the arrow. So we have calcium and we have oxygen. All right, we have 1 calcium on that side, 1 calcium on this side, 2 oxygens on this side, 1 oxygen on this side. All right, not balanced. So again, we're going to go over here. We need 2 oxygens, so we're going to put a 2 here. That 2 gives us 2 calciums. It also gives us 2 oxygens. We've unbalanced the calciums now, even though the oxygens are balanced. So we have to now go over, put a 2 here to get 2 calciums. Now we have 2 calciums, 2 oxygens. All right, so that's just like the one we did, except with different elements. Okay, as we slide down, you can pause this one. All right, so now let's look at the next one. So this one we have 2 elements also. We have nitrogen and hydrogen. Okay, so we have 2 nitrogens on this side. We have 1 on this side. All right, what I even recommend doing is when you have something unbalanced, I find it easy to go ahead and balance it. So we need 2 on this side. So let's go ahead and put our 2 there. And so if we go ahead and change that, now we have 2 nitrogens over here. Okay, now we're going to go ahead and count, but now we've already adjusted this one. So we have 2 H's on this side, and we have, over here we have an H3 out here, but we already put a 2 in front. So that says we have 2 H3s, which means 2 times 3. So that's 2 times 3. So now we have 6 H's over here. All right, we have 6 H's and 2 H's, so we need to get 6 on this side. So what number do we need to put up front in front of H? Well, we have a 2 there, so it needs to be, in order to get 6, remember it's multiplying, so we're going to put that 3 there. So that 3 is 3 times 2, which gives us 6. 2 and 2, 6. 6 and 6. Perfect. All right, go ahead and pause for the next one. All right, so let's look at the next one. So this one we have 3 different elements. We have copper, we have oxygen, and we have carbon. All right, first off, we'll start with the copper. The copper, we have 2 over here. So we're going to go ahead put our 2. We only have 1 over here. Well, again, if we want to go ahead and balance it, we can go ahead and put a 2 there. So now we have 2 coppers and 2 coppers. Okay, oxygens, we have 1 on this side. We have 2 on this side. Right? Since we had 2 on this side, we need to go ahead and adjust this side to get 2. So we got to put a 2 there. So now that gives us 2 oxygens, but it also gives us 4 coppers. Okay, 4 coppers means we're going to have to change this one. And normally you want to be using a pencil. I'm using a pen just so it shows up better. But you want to be using a pencil so that you can erase this, because it will change. It is like a puzzle. You're gonna work your way through. That's what I love about balancing equations, is solving the puzzle. That's what you're trying to do. And so now you put the 4 there. So now you have 4 on this side. We have 4 and 4, 2 and 2. So how many carbons do we have? We have 1 on this side. We have 1 on that side. It's balanced. All right, so now we have 4 and 4, 2 and 2, 1 and 1. Balanced equation. It has 2 copper oxides, 1 carbon, 4 coppers, and 1 CO2. Now, which brings up the question of, do you put 1s inside of here? Well, as we know in science, we don't write 1s. We don't write 1s when they're actually there, and but that does mean there are 1. There is 1 of each one of these, but we don't need to write the 1. The only time you might see a 1 written is if you have multiple choice questions of which numbers would balance this equation, and the correct answer would look like this. It would be 2, 1, 4, 1. Okay, so that would be how you would see the 1s fitting into there. Okay, and so just to let you see that. Okay, go ahead, pause it one more time. All right, let's look at the last one here. And so this one, you see we have 2 elements, H and O. Okay, H, we have 2 on this side. We have 2 on this side. Oxygen, we have 2 on this side. On this side, though, it's a little different. So we see we have 2 oxygens here and 1 there. So 2 plus 1 is 3. Well, we know we don't want to increase the even number over here. We don't want to increase the even number because it's still going to be odd when we add it to 1. So we need to get this odd number, which is just 1 of them. We need to get that to an even number, because this side can only go up by even numbers. So we can balance, when we go to balance it out, we have to have an even number on this side. The only way to do that is get rid of this odd number. So first off, we can try by adding 2. 2 times 1 makes this 2 now, so that's an even number. 2 plus 2, we have now 4. We also have how many hydrogens? 4. Remember, anytime you add a coefficient, you have to adjust both chemicals that it affects. So now we have 4 and 4. So we go to the other side. We need to get 4 hydrogens, so we need to add a 2. 2 times 2 is 4. Oxygen, 2 times 2 is 4. 4, 4, 4, 4. Hey, perfect. And that balanced it. And again, this would be written out. This would be 2, 2, 1. That would be the coefficients for that. All right. Well, I hope that helps and gives you a good start. What you're going to want to do today is do the practice problems here in balancing equations, PA 6.5. And as you do these, there is one other thing that I want to show you. So I'm going to do the first one with you, and then let you do the others. Okay. All right. So let's look up at number 1. Now, number 1, what you see is we have 1, 2, 3. We have a groups of 3 elements. That means we have a polyatomic here. Well, what's cool is anytime you have a polyatomic, you can simply make sure the polyatomic's on both sides. And if you put parentheses around it like this, you can see and compare. Is the polyatomic the same on both sides? Yes. Okay, as long as it is, then you can simply balance the polyatomic. You don't separate it into separate elements. Okay? So, in this case, we have Na, we have PO4, the whole thing, we have K, and we have OH. So how many NAs do we have on this side? 3. This side we have 1. So we need to get 3 of them. So we're going to go ahead and change that. All right, PO4s, how many do we have on this side? Well, it's PO4, so there's only how many of them? Because remember, our parentheses goes around that. There's only 1 PO4. How many PO4s on this side? 1. How many potassiums or Ks on this side? Well, we have 1. How many on this side? We have 3. So because we have unbalanced, we need to get 3 on this side. The only thing we can do is add 3 there. By adding that 3, now we have 3 Ks. And then we also get 3 OHs, which is our next one. So 3 OHs on this side. How many OHs on this side? Well, here's that 3 goes to that OH. So we have 3. So 3, 3, 1, 1, 3, 3, 3, 3. Perfect. Balanced. All right. Balanced. So as you guys go down and work through, if you have any questions on any of them, you're welcome to use the try working them out, see if you get them right, and then check on the key that I've placed down on the bottom right of the sheet. All right, I hope that helps a bunch, and I'll post a well, here, let me just show the key here, just so if you're looking. All right, hope that helps a lot. And anything I can do, post your comments in here and I will respond. Let's get balancing equations. We got this.